Designing a proper test for the life of an electromechanical component involves several steps and considerations. Here's 6 steps proposed to do. 1. Define the test objectives. Clearly outline the expected functions and specifications of the component. Identify potential failure modes and criteria. This step is crucial to ensure that the test is aligned with the design specifications and customer requirements of the electromechanical device. 2. Choose the test methods. Depending on the type, function, and complexity of the system, various test methods can be employed. These include functional testing, performance testing, environmental testing, endurance testing, and accelerated testing. Accelerated life testing is a process of testing a product by subjecting it to conditions such as stress, strain, temperatures, etc., in excess of its normal service parameters to uncover faults and potential modes of failure. 3. Prepare the test setup. This includes the test equipment, the environmental conditions for the test, and the test parameters. 4. Perform the test procedure. Conduct the tests within the rated operating conditions for a sufficiently long duration. Periodic observations should be made to identify wear-out failure modes. The test duration, voltage, and temperature depend on the acceleration factor used for testing and on the activation energy of the component. 5. Analyze and report the test results. After the test, analyze the results to identify the failure modes and mechanisms. This can be done by failure mode analysis of the designed product associated with the intended use. Report the test results, highlighting any issues or limitations of the test process or results, and recommend any improvements or actions for the component. 6. Failure analysis. If a failure occurs during the test, a systematic failure analysis test sequence can be formulated and performed to establish the root cause of the failure. This process involves analyzing the component data or the component itself to determine the cause of the failure. Remember, no single acceleration model can address all possible failure mechanisms of complex assemblies and components. Therefore, the challenge is to find the most relevant failure mechanisms to investigate. It's also important to conduct tests regularly and thoroughly to ensure the components meet the required standards and expectations.